Nicholas Hellstrom, and we're super delighted that Raymond Pierrehumbert is joining us from the British Isles. In fact, you've changed your backdrop again, and it's Ray is not only a completely fantastic climate scientist who has done massive amounts for our understanding of the climate, spanning. What impresses me with Ray is he does everything. He's an atmospheric scientist who also works on ancient rocks. And it's, so there's basically nothing you're going to be able to throw at Ray that he's not going to know something about.
Well, and I'm especially interested. We've gotten really into silicate weathering now too for exoplanet studies, but we're really trying to catch up with what geologists know about silicates right now. So, and it's fascinating. I'm just learning more and more about rocks and minerals.
That's you're welcome into the field of geology as well, Ray. We need you there. But one of the things that Ray talked to me about when I met him a few years ago. Sorry. One of the things Ray mentioned taught me about a few years ago in Stockholm was something scary which he called aerosol hacking, and that is what the focus of this evening's session. Manipulating the stratosphere. And Nicholas has brought to our attention that there is an attempt now to do a test experiment in Sweden. And this is why we're all together. And I'm hoping that the outcome of this session is not just going to be that we're going to have an interesting discussion. We're going to hear some interesting talks from both Nicholas and Ray on this topic. But we need a concrete outcome because this is planned for June, and action needs to be taken to make sure that Sweden is famous for many things. Sweden brought Bert Bolin. Sweden is instrumental in the foundation of the IPCC. Sweden has brought the youth movements. I for one do not want to see Sweden bringing aerosol hacking to the world. So it is very much time to listen to Nicholas and Ray, and then to work out how we're going to act, and very, very quickly. So this evening, Nicholas is going to give a brief introduction to why we're all here, and then we're going to hand over to Ray, who is the expert on the topic of, forgive me for calling it aerosol hacking, Ray, but that's the word you gave to me, and somehow it really captures it for me.
Yeah, and sometimes I call it albedo hacking.
Albedo hacking is probably better.
Because that's what they're hacking in the end. But yeah.
So albedo hacking we're going to learn about. But so Nicholas, I understand you're going to give us an introduction. I'm handing over to you, and then you just hand yourself on to Ray. Now, for the actual presentations, it's great if everyone mutes. You're very welcome to have your videos on. If you find their videos are in the way of the presentation, just press exit full screen and you'll see the presentation without videos in the way. I'm going to ask people to write questions into the chat. I won't be interrupting the speakers, but then I've got that list of questions that I'll start, and write them as they come into your head. And I'll take them after the talks in the order that they show up. So do feel free to throw in questions straight away, and discussion points and whatever. So enough for me. Oh, if I didn't say who I am, I'm Alistair Skelton. I'm a geologist. Nicholas, would you be able to take over?
Sure. Thanks, Alistair, for that introduction, and great to see everyone. Taking hours of your precious evening for this. That's super good to see. I think we will need to do quite a bit of work. At least some of us are already doing that on this issue. But I think the point here, just to set it off, is really to be having a very open-ended conversation. This is a very explosive topic. It's a fairly new topic for many. There's obviously controversies, and we're for sure not assuming that everybody's aligned. And I think that's sort of the spirit of Researchers Desk too. It's to have a space where we can really discuss and figure things out. And when people want to come together and take action, which has been happening before, including the the organization had their op-ed and so on. That's great, but it's you know, maybe not Researchers Desk as an organization that necessarily is taking a stand. If we do, we want to, of course, that's a process to figure out. So just to say that this is to be really a frank debate and discussion, and everybody's really welcome to chip in as we move along. And we're super grateful to have Raymond here, and also Bengt Gustafsson, who hasn't been, I think, involved with the Researchers Desk until now, but we hope to see you in the future, Bengt. But I've also been discussing this quite a bit with Bengt, whom I know since early CEMUS days. Bengt was instrumental in getting CEMUS on its feet when we as students came and wanted to do something crazy back in the days. So just to set it off a little bit, I guess also to say that for me, the context of this is it's not a new issue. I've followed this for a long time, and some of you know I'm wearing several hats, which I should be clear upon as well. I have a CEMUS connection, the University of Uppsala, but I've also been working a lot with my own What Next platform, think tank which came out of the Dag Hammarskjöld Foundation, where I spent almost 15 years in Uppsala, where we brought people together to bring up new issues and catalyze action, sort of scholar activist settings, really crossing the interface between policy and research and advocacy. And in that capacity, also working very closely with the organization RAFI, that later changed name into ETC Group, and is one of the civil society organization that has followed these issues the most closely and for the longest time, I would say, and really brought attention to a lot of these things early to people. So I'm in the board of that organization as well. And the topic of geoengineering really came to on our radar through RAFI collaboration early 2000, the year 2001 maybe, and that was, nobody had ever talked about it really. It was sort of new, and people were wondering why we had seminars and started to focus attention on something that was so crazy and out of hand and just wouldn't be something to bother about really. Seemed pretty off the chart and mark. And I think that's where I'm coming into this, with that perspective of over now 20 years, seeing the issue of geoengineering and different kinds of geoengineering, with even now solar radiation modification, like the more extreme form of this whole sort of package of technologies that are labeled geoengineering, become much normalized, socialized. There is a trajectory that I just take a step back, and it's pretty frightening in my view, because I see how society seems to be really on a trajectory, especially now with the climate crisis obviously being much more upfront, much closer, much more sort of urgent climate emergency, etc. So I've followed these issues. People are aware, but few people have really bothered to kind of including in civil society to kind of really engage, because it's always been a sort of marginal thing, and again, not something that really is happening. But I think with what we're going to talk more about today is it becomes, you know, it hits home clearly. Scopex, this particular project that has plans to initiate their open air flights and eventual or soon to be release of aerosols in the stratosphere, has been going for a while as an idea and as a project, and I think Raymond can talk more about that. He's followed it quite closely, and we've had our eyes on it. It has not succeeded to do what they intend to do in Kiruna yet, and there's been quite a lot of controversies around this. The attempts to do initial flights were in I think in New Mexico and Arizona, but that didn't happen. And I don't need to go into the sort of, I think the details of the technology and how it's supposed to work, and I'm sure Raymond will touch on this, and we'll have conversation also as we move on for tonight. But just to give you a sense of sort of what seems to be happening, I think from the write-up you're clear that the idea here is to to initiate a process of experiments with balloons up in Kiruna to release aerosols. And the reason for this, stated reason, is to do research and understand better how these aerosols, react with the chemistry, but also how they spread, and supposedly give information to further development of a technology that could be possibly applied at a very, very large scale, which is the whole point of this. It can only make any sense if you do it in a very, very large scale to have any dent on the temperatures. And I think for many observers, it's very clear that this is partly a pretext, at least in terms of the research agenda, and it certainly has a very political dimension. It's about to really socialize, break new ground, cross borders, and especially if this happens in Sweden, it would be a very, very significant sort of breakthrough for the advocates or proponents of the technology, whether they are proponents to actually deploy or proponents to develop it so that we can possibly deploy. There's of course a gradient here as to where people are, but I think many people, including myself, take a stand where we see that this is a very dangerous boundary to cross, because there is such very, very fundamental problems with the technology that we are going to have major difficulties to handle if we go too far and set emotional, political kind of a process that takes its own life, really, and that's what we see now. And I think my observations too, from just seeing the sort of number of webinars and the kinds of discussions and debates and op-eds and political interactions, and capacity building of government people in the South and so on, by folks who are clearly very excited about the prospect of developing this technology. It's mushrooming. It's going really, really fast, and there's a strategy, as far as I can tell, behind this. And I think we need to understand this Kiruna case also in light of that. It's part of a larger wave of efforts to advance the possible development and eventual possible deployment of the technology. I want to say more now. I think we'll get back, and Raymond should get more time. But in terms of responses to this, it came as a surprise. The announcement that Scopex would do something in Kiruna was, I think, published on their website on the 15th of December. So it was just a few days before holidays. So nobody really had much time to figure out what was going on and of course respond. There were some articles. I think you've seen some of the links in the mailing for this meeting. And people are certainly waking up and have been waking up, and there's been quite a lot of work behind the scenes. People are in civil society for sure, synchronizing, mobilizing, writing letters, coordinating, and are about to really make this a real issue. And that's of course, for in a Swedish context, that's clear. We have the Swedish Space Corporation as a key entity, but also the government and others. So there's quite a bit happening, and we can get back to some of that as we move into discussion maybe. Research community, I think, has been silent so far, but again, it's kind of new, and there hasn't been much media yet. But I've had conversations with Bengt, for example, and I know there's growing awareness and a lot of concern. So it's very timely to have this conversation. We've seen some attention in media, but not like a big splash. But I think we can expect possibly within a week or two that there's going to be quite a lot of attention. I think we all want to be prepared and understand the issue as much as we can as that happens. We have now an interesting situation with the new Minister of Environment entering at any day. So this will be the first hot potato, I suppose, for the new Minister of Environment and Climate. But of course, this also crosses many boundaries. It's not just a climate issue, obviously. And we have what else? Well, there's I think basically a storm waiting to happen. And yeah, that's what I was going to say. On the 15th of February, there's going to be a meeting, and there's been an announcement of a meeting of the steering committee or the advisory committee of Scopex, which is supposed to give a clearance for this project. If the project says that if they don't get a green light from the advisory committee, they will not proceed. That has been a lot of controversy around this committee. It was set up by the project. It's all Americans, and it's fairly narrow, and it's not been consulting with, wider constituencies. So I think we expect it to be just basically rubber stamping, but we'll see what happens. And that's an entry point also for intervention or for engagement, obviously, for whoever. And that's quite soon. So that's one point in time to take note of. The experiment is said to be planned for summer, and they've also said, if you read carefully the documentation on the website of Scopex, that it is supposed to be, they hope to be, this will be the first flight, and that there will be subsequent flights and with release of also aerosols. The first one is just to test equipment, but it's obviously set up to enable the next step of release. As you also might know, there is a moratorium on geoengineering generally, where SRM or stratospheric aerosol injection is certainly one covered. And that was an achievement that Sweden actually was very instrumental in getting through the Convention on Biological Diversity 10 years ago in the UN negotiations under the Biodiversity Convention, and it's been maintained. It's a consensus decision of 196 countries, but there's some gray zones in there. There's provisions for small-scale experimentation and in controlled settings, and the Scopex proponents, led by David Keith at Harvard, are of course going to be maintaining, or they've framed it already as this is small and controlled, and we don't need to ask for permission. So we understand that they have not been approaching any government channels or Naturvårdsverket or any other agency in Sweden to ask for permission. They've basically just signed a contract with the Swedish Space Corporation. Maybe I'll stop there just to let Raymond take over, and then we'll be on a route for a very interesting conversation. So Raymond, please, it's looking forward to hear your thoughts. You've followed this and written really extensively about the issue, and including Scopex as itself. So
yeah, okay, good. So so thank you. Let's see. Yeah, I'm unmuted. Does
by the way,
everybody
Raymond, just one question. This is really, of course, to be the idea here is to have a very open-ended conversation. But I wonder, if you're doing a presentation here, would it be okay if Toya records and we could see if there is a snap snippets to possibly make use of, or would you be?
Oh yes, no, that's perfectly fine. Actually, everything I'd say here is stuff I've said in public, other places. And I'm going to show a few slides, but I'm not going. I want to keep this as an informal discussion. So everybody should feel free to just jump in with questions. Whenever you want. I have trouble monitoring the chat box while I'm talking. So if somebody else can keep an eye on the chat box and just relay any questions, or just jump in by sound.
If you want to make a question that you'd like to interrupt the talk, indicate that in the chat, and then I'll interrupt Ray with your question.
Yeah. Okay. Yeah. So okay, I'm just trying to get my pointer up. Yeah. Let's see. Okay.
We can see your pointer, Ray.
Yeah, actually, no. I was trying to get my annotation. That's okay. I don't really need the annotation tool. I'll just yeah. There. Okay. Yeah. So I thought, just to make sure everybody's on the same page, I would go over the basics of what this albedo hacking scheme is, and then go into why general issues on why this is such a terrifying and destabilizing thing. It's a technology which has no real good justification for deployment ever, and it's not something where I think further experimentation is going to tell us a safe way to deploy it, because there are intrinsic problems with it, which I'll go over. So it's a case where the risk of research is that it will create the technology that will make it possible to deploy it at a time when we actually have no idea that there could conceivably be a safe way or a responsible way to deploy this. So, so to give you the general, well, actually, to explain the terminology first, there are a lot of different names for this particular way of messing with the climate that are floating around. The early proponents called it something called it SRM, or solar radiation management. And a lot of us really objected to that term, because it implies that this is a system we understand so well we can manage it like you can manage inventory in a shop, just a routine thing to do. And so then, people have tried to repurpose the acronym and call it maybe solar radiation modification, or I've seen one article where they called it solar radiation mitigation, as if sunlight was a problem that we had too much of. So that's not so great either. So people also call it solar geoengineering. But in the National Academy report, we didn't like the term engineering either, because you do engineering on a system where you understand the outcomes. You also do engineering on a system where you can do a scale model and understand how it behaves and try it out in a safe way before you scale it up. This kind of technology is something where we won't know what it actually does until you deploy it at scale. So there's really no way to answer the essential questions until you actually do it. So it would be engineering in the sense that trying to install a new engine on a 747 that's in flight would be engineering. And it would be a completely different kind of engine running on hydrogen instead of kerosene or jet fuel. So it's just there are all sorts of problems in the terminology. So in the National Academy report, we called it climate intervention. We call this class of things climate interventions in various flavors, like climate interventions by reducing sunlight and so forth. I like to call it albedo hacking. I guess the neutral term is albedo modification. So I'll just call it albedo hacking or albedo modification. But albedo refers to the reflectivity. And so it all goes back to the most basic aspects of climate, that going back to Fourier in 1827, we know that the temperature of a planet is determined by the balance between the energy in and the energy out. And the energy in for a planet like Earth is through sunlight. So you have a sunlight that comes in, you have a certain amount that's incident on the atmosphere from the sun, and then a certain amount of that is not absorbed by the Earth system, but is reflected back to space. The portion reflected back is called the albedo. And so a certain amount of energy gets into the Earth. It's on the average about 280 watts for every square meter of the Earth's surface. And then the infrared radiation, just black body radiation, the hotter something is, the more infrared it emits. For things at roughly Earth-like temperatures, you get infrared out. So the only way a planet loses energy is by infrared. So the planet heats up until it radiates enough infrared to balance the incoming thing. And so when you add carbon, so this is the red arrow, is the outgoing infrared, which in pre-industrial times is on the average in balance with the amount of absorbed sunlight. And now what happens when you add carbon dioxide to the atmosphere is it's like adding insulation to your house. It means that the Earth has to get hotter in order to lose the same amount of energy. So if you keep the sunlight the same, but you reduce the amount of infrared going out by putting carbon dioxide in the atmosphere, then the system's out of balance and it's getting more energy than it's losing. So it has to warm up until it comes back into balance. Okay, so now the idea with albedo hacking is that okay, we've reduced the infrared radiation going out by increasing the CO2. That's the smaller size of the squiggly red arrow. But to keep the Earth from warming up, we work on the other part of the energy balance, which is the amount of solar heating. So the idea is to reflect more sunlight back, in particular by injecting particles into the stratosphere where they stick around for at least a year or so. Reflect more sunlight back so that you're in balance with a lower amount of carbon dioxide. But it's important to recognize this already is a massive disruption of the climate system, because the way that incoming sunlight acts on the Earth is not identical by any means the same as the way outgoing infrared acts on Earth. And in particular, incoming sunlight reaching the surface is what sustains evaporation to make rainfall. Incoming sunlight has different strengths at the poles versus the equator. Carbon dioxide, not so much so. So to equalize that distortion you're doing to the distribution of energy, the circulation has to do all sorts of stuff. Incoming sunlight does things like affect photosynthesis. It's what plants live off of. And there's a difference between sort of direct sunlight and diffuse sunlight that you get from scattering. So there are all sorts of reasons that when you do this, it's like you clobber the Earth with one sledgehammer and say, okay, we're going to fix the problem by clobbering the Earth with a different sledgehammer and hope nothing breaks. So, we've broken the system, so we'll break it a little bit more. So it's like some people refer to this as, okay, stupidity got us into this problem, so maybe more stupidity will get us out. That's not the framing David Keith likes, but I think that's a true description of the situation. Okay, so the way that the way that stratospheric albedo hacking works is that you inject something up into the atmosphere that makes small particles. So it could be sulfur dioxide, which turns into sulfate aerosols that are small particles that are good at reflecting sunlight. It could be something else. Keith's group has even proposed diamond dust, if you can believe it, which has a better index of refraction than sulfate aerosols. And they're pushing the idea of calcite, calcium carbonate particles instead of sulfur dioxide. But whatever you put into the stratosphere, the idea is you put something in that makes small particles, and small particles per unit mass reflect a lot of sunlight back. And it doesn't actually take a lot of mass of this stuff to reflect back sunlight. And people want to, Keith's group wants to put this in the stratosphere as opposed to doing something down near the ocean surface, because a particle down near the surface gets washed off by rain in about 7 days. The stuff up here stays up for maybe a year or two, as you can tell by how long the cooling from a giant volcanic eruption like Pinatubo lasts, which is on the order of a year and tailing off in the second year. That's why some people call this artificial volcanoes. Volcanoes do this by putting sulfur dioxide in the stratosphere, which turns into sulfate and makes aerosols. So that's the general picture, and I may come back to this later, but if you look at the research at the sort of the rather small research environment in solar geoengineering and albedo hacking, a rather disturbing thing is that the big backers is the tech industry. They're big backers among Silicon Valley moguls, Silicon Valley billionaires, who really like this idea. So it's sort of famous that Freakonomics, the Steve Levitt popular economics textbook, was arguing that this is the obvious cheap way to address the global warming problem. And he was drawing on Nathan Myhrvold, one of the Microsoft billionaires, who in fact has patents in various aspects of injecting stuff into the stratosphere and sees this as a way of making a lot of money. There's a lot of just sort of techno optimism behind it. And one of the big lobbying groups that's actually gotten legislation introduced into the U.S. House of Representatives to fund geoengineering, though it hasn't passed yet. One of the big lobbying groups is a group called Silver Lining, and their list of donors, it's just like a list, a Silicon Valley who's who. Harvard's group on this, led by David Keith, it's funded by Bill Gates' personal fortune and various other donors. And there's a whole lot of sort of what you might call astroturf governance groups that purport to be just looking at ways to govern geoengineering and being neutral, as they claim, about whether they want to deploy it. But in fact, these groups like the Carnegie Group on Governance, the SRMGI, Solar Radiation Management Governance Initiative, all these things which are funded by private endowments, they really are serving to increase the comfort level with the idea. They're not looking at whether this should just be banned outright. They're trying to make the third world comfortable with the idea that they'll be better off with this. They're just doing a lot of stealth advocacy. So there's a lot of there's just a lot of nastiness going on with the advocacy for this sort of stuff, and it's sort of building momentum, especially in the U.S. right now. And so I find it especially threatening, but especially nasty, that to try to sneak this in under the radar screen, David Keith is trying to do his technology development in Sweden, where for some strange reason he expects it to get less attention than if he were doing it in New Mexico. And I think it's truly nasty that at a time when Sweden is struggling with its own COVID problem and has lots of other problems to deal with, and people are distracted, he's trying to pull a fast one by making this secret deal with Rundbolaget to conduct this in Kiruna. I don't even know if he's been in Kiruna. He probably imagines that Kiruna is out in the middle of nowhere where nobody ever goes, and would never notice. I have no idea what he was thinking of. But so I'll get to what the ScopeX experiment is in a bit. But now I'll just say I'll unshare this screen and share a different one. Yeah, seriously revolting mess. That's a great term that Kevin Noon was introducing here. Let me find, let's see, I'm looking for my other, let's see, where's my other talk? Put away this one. Oh yeah, here he is. Okay, there's this. Oh, here it is. Yeah, okay. Yeah, I got so many screens open. It took me a while to find it. Okay. 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 This is actually from a talk that I gave at Harvard. That previous slide I showed was from a talk I gave at the Bolin days, I don't know, 5 years ago, to show you how long this stuff has been going on and how long it's been building. This is from a talk I actually gave at David Keith's group at Harvard. So, and I'm not going to go through the whole thing, just a few highlights. To introduce you to the most dangerous thing about albedo, stratospheric albedo hacking, I want to introduce you to the problem of what I call termination shock, or the millennial commitment, which is the mismatch between the lifetime of carbon dioxide in the atmosphere and the persistence of the stratospheric particles that are put up to try to cancel out global warming. Okay, so and the basic thing is carbon dioxide has such a long lifetime, it accumulates in the atmosphere, whereas the aerosols don't. So the longer you emit CO2, the warmer it gets and the more CO2 there is. And if you stop emitting CO2, the warming doesn't go away for thousands of years. If you stop putting up sulfur dioxide or particles in the stratosphere, the cooling effect of that goes away in just a year or so. So you've got to keep on doing it. And if you keep on pumping out more CO2, which is likely if people cool the earth by injecting some aerosols, means each year you continue to pump out CO2, you have to ratchet up your geoengineering more and more. So you get into this death spiral, more CO2, more geoengineering. Then eventually there's a war or something and you have to stop. And then you're hit with all that pent up global warming in a matter of 10 years or so. So I'll show you some graphs of that. So that's what we call the termination shock problem, or the millennial commitment problem. And it's truly terrifying. So just to introduce you to the general idea of the sort of irreversibility of CO2 induced climate change, one of the innovations in thinking about carbon dioxide and climate is the notion of cumulative carbon. So cumulative carbon is the net amount of carbon emitted as CO2 in the entire past history of the world. Let's just say the world. Okay, and it's been found that the global mean warming is roughly linearly proportional to the amount of cumulative carbon that you've emitted over all past time. So this is something that only increases, it never goes down. And the amount of warming at the time emissions stop is nearly independent of the emissions trajectory, whether you emitted a lot early and less later, or vice versa. And the amount of warming at the time emissions stop lasts for about 1,000 years without declining. And then it declines only very gradually over the next 10,000 years. And it takes well more than 100,000 years for things to return to pre-industrial states. And 1 trillion tons of carbon is roughly equal to a 50-50 chance of keeping warming under 2 Celsius. So this is from a paper in Nature Climate Change with dozens of authors that I was involved in some years ago. Let's just look at the temperature. So this is the temperature over the past 20,000 years, going back into the depth of the Ice Age, okay? And then these lines are the temperatures you get if you emit various amounts of cumulative carbon. This is about 1 trillion tons, which is what we're in line to do. And right now, well, actually, we're in line to exceed that if we don't stop. Okay, this is 2,500 gigatons, 3840, and roughly 5,000 gigatons. Okay, that is the top line there. Okay, so in all these scenarios, you emit a certain amount of cumulative carbon, and then you stop. Then you stop after 200 years. You stop by 2200. And so at the point you stop, that's when the temperature has a chance to keep going down, but it does go down very much. So here it says if we do wind up emitting 5,000 gigatons, the temperature goes up by 8 Celsius global mean, which is bigger than the warming coming out of the last ice age, but in a direction and at a speed the Earth has never experienced in billions of years of Earth history. But then what's really alarming is even out to 10,000 AD, that curve hasn't gone down very much. But now if you, these are the left-hand side are temperatures in geoengineering scenarios with termination using a model. But let's look at using a full GCM, and the right-hand panel is from from a simplified energy balance model, which tells the same story. And so what's done here is that you've continued to emit carbon dioxide, giving a certain amount of warming, and then you have then you have cooled the planet by introducing some geoengineering, and now then you stop at various points. So if you stop at this point, this rapid rise is the warming you would see, which would bring you back up to the curve you would have been at. So you're ticking along fine here. You say, oh, it's nice and cool. I can just keep on emitting CO2. Okay, now we discover some adverse consequence, or India is getting in a war with China because India's monsoon is getting clobbered and China wants to stop heat waves. And speaking of that business of non-uniform effects, geoengineering, given that it's more beneficial in some places and more harmful in other places, it sets up the world for a struggle with who gets to decide on the climate. And you can bet that this is just going to be another way for the first world to impose its will and clobber the third world. If it's a matter of Uganda or London, picking what climate is best, you can bet which one is going to win. But then when there's the increase in tensions, international tensions over disputes over what climate you get, you can imagine the scenarios for destabilizing an already unstable world. But anyway, here's the termination shock. You're ticking along, you think it's fine, something happens, you have to stop. And then you shoot up here really fast. And the longer you go in this death spiral, just happily emitting more CO2, the bigger your termination shock when you finally stop. And the only way to avoid the risk of termination shock is to have an agreement. Is to have an agreement that we're only going to do this after the CO2 emissions rate has gone down to a very low level, and an agreement that we will never do more than, say, a ½ degree worth of geoengineering, where you might have a acceptable termination shock. But the political system, which has not even been able to agree on reasonable things like decarbonization, it's not. We're not living in a world where you can count on the political system to actually stick to an agreement to keep this in the box. I used to say, the kind of world where you can elect, where the most powerful country in the world can elect a president, Trump, who says that it's a good idea to drink bleach to fight COVID. That's not the kind of world you want to unleash geoengineering into. Okay, so I'll just do one other. So that's the millennial commitment problem. If you get into a situation where you need it, you're committing humanity to do something without fail for the next 10,000 years. When have we ever accomplished anything like that? No. And then here's another thing. This is sometimes called moral hazard, but I think moral hazard, which comes from the insurance industry, understates the problem, because we have no way of sharing the risk. There's only one world at risk here. We all have to live here. But the general idea, the way I would phrase what's sometimes called the moral hazard problem, as a species, we tend not to take action or to depart from a comfortable status quo until the problems actually start to become manifest. So what does geoengineering do? What does albedo hacking do? It removes the symptoms of CO2 emission without removing the underlying cause. And so if you don't see the problems, where's the push to actually do the hard work to decarbonize? The most likely thing to do is to do some geoengineering. You bring the temperature down to where the problems seem tolerable, and so you emit more carbon. Then you have to do some more, bring it down again, and before you know it, you're in the situation with a really lethal termination shock waiting for you. And now, David Keith's bunch and various sociologists, economists, have done these sort of questionnaire sociology studies where they argue that moral hazard is an overestimated risk. But my answer to that is, when have sociologists or economists ever been able to predict anything? Or if you look at it this way, when has the tech industry ever been able to predict the effect of disruptive technologies? If you look at how little we anticipated what Facebook was going to do to civil discourse, how can we really have any confidence whatsoever that introducing a disruptive technology like albedo hacking is going to be handled in a manageable way? It's just not possible. Okay, and so the part of this fallacy is part of the fallacy of behind a lot of the rationale to develop geoengineering technology is the Plan B fallacy, which basically says, okay, we don't want to do this, but we don't seem to be making progress on decarbonization and reducing emissions, so we need to develop this just in case. But that's just the worst possible justification for geoengineering. There may be some justification for geoengineering after you've already brought your carbon emissions down to essentially zero, where you might only need just a little bit of geoengineering. But the idea of doing it instead of reducing carbon emissions is absolutely loony, because each year you continue emitting carbon, you need more and more geoengineering, and you incur more risk of termination shock. So one of the standard line, and this is very easy for newspapers to pick up, is that we need to do the research just in case, as a kind of a backstop. But this isn't a case where it's a just in case thing. There is no plan B if we don't there is no workable plan B if we don't manage to bring our emissions down to zero, and pretty soon. So I'll stop with the I'll stop with that sort of introductory stuff first, and then I'll just outline Scopex. And so the only, almost essentially the only physical science experimentation on deployment of geoengineering albedo modification that's being done in David Keith's group at Harvard. He and Harvard, with a lot of backing from the university, which loves to see itself as being in the vanguard, whether it's good or not. David Keith's group has been sort of single-handedly keeping the subject of geoengineering research alive. Okay, now there's a lot of simulation work going on in other places, but Harvard is the only place that is actively trying to develop the technology to do this. Okay, now their line is that they're just developing technology to test out some principles that would be used. But the fact is that because of things we don't understand about clouds, the climate system, we won't know how the climate system or the social-political system will respond to this until you do it at scale. So these small-scale experiments don't even address the most critical questions about what this technology would do. But what they do is they develop deployment technology. Whether it's developing balloon flights or whether it's developing technology for dispersing aerosols. It develops nozzle technology. It develops the technology for actually dispersing calcium carbonate aerosols, things like that. It definitely contributes to the engineering aspects while not contributing anything to the big unanswered and unanswerable questions. And so Scopex, so there's never been a stratospheric physical experiment done. So Scopex is an incredibly dangerous line to cross. And once you do it a little bit, that's the thin edge of the wedge. It's crossing the Rubicon. It makes it easier and easier to deploy bigger and bigger experiments. And so although Scopex itself does not release enough material to have a physical threat to anything, it has a huge socio-political threat in terms of opening the way to other and bigger experiments. It just moves the boundary, and it's really a threat. And so to actually have Sweden be in the vanguard and do the world's first stratospheric deployment of geoengineering technology, even if it's not with a release of substances, with the first balloon flight, that would be a scandalous thing to happen. And to have this happen sort of under the radar without asking for any kinds of approvals or even widespread discussion with stakeholder agencies in Sweden, that would be an even bigger scandal. So what Scopex actually it consists of is a balloon with a Kevlar filament, and the idea is to drop an aerosol squirter descended from the balloon to release aerosols in certain patterns, and then you want to see if you can detect those aerosols in the atmosphere and find them to see what happens and what's their particle size, how dispersed do they get, things of that sort. It's a little bit unclear what the ultimate deployment is for the detection, but one possibility is to try to detect the aerosols from the same balloon where you deployed them. And I think in the longer run, they want to use the balloon for deploying the aerosols, but then run aircraft, instrumented aircraft, to try to find the plume and measure its microphysical properties. So, but this is all done in the stratosphere. So it would be done with very high altitude aircraft, and probably monitoring it by balloons would be the easiest way to actually deploy something that could detect the aerosols. So what the Kiruna experiment is all about is to test the balloon technology. And ultimately, this would be followed by actual releases of aerosols. But even if the release of aerosols didn't happen in Sweden, the balloon technology test is what would enable Harvard to do this experiment wherever they can find some country gullible enough to let them do it. And that's why I think, you know, there needs to this needs to be stopped in any way, in any way that it can. And that's all I have to say about that.
Thank you very much indeed, Ray, and thank you also, Nicholas. Thank you, Ray, for also giving us some background to make sure everyone's really understanding what this is about. As you might imagine, the chat is completely full of questions. I'm going to run through a few of them, and we'll see how well we get on. What I'm probably going to do is I'm just going to invite the person who asked the question to jump in. The first questions were are actually are asking who gave the green light for the experiment. There's a few questions on the same theme. So who actually said it was okay to do it? Does anyone, Nicholas or Ray, do any of you have any idea able to answer that question?
I have no idea. Maybe Nicholas knows. From all I can tell, from the most I can tell, it is somebody in Rymdbolaget.
Okay.
It was probably, I don't know whether Rymdbolaget was fooled by the experiment being described as just routine balloon technology, or whether Rymdbolaget actually made the decision knowing that this was a preparation for geoengineering. That's the sort of thing we have to find out, you know, before anything else. Well, not before anything else, but that's a critical thing to find out, is who actually made the decision.
Nicholas, do you have a reflection on that?
Yeah, I mean, it is not entirely clear what's been going on, but from everything I've been able to find out, there is no indication that Scopex and David Keith has been in direct touch with either the Naturvårdsverket or the government when they were alerted by us and were completely unaware. Everybody I've been in touch with, at least, one would assume they would have had some underhand contacts because to cover their base and make sure it wouldn't backfire, but we haven't seen any such indications. But of course you can't really know, but it seems for sure that they haven't done anything formally. There's not been any sort of approval, permission, correspondence in that order that we've seen. So it seems at least that they just been cutting a business deal with Kiruna, with the Space Corporation, which is a profit-making, our state-owned company, and they do balloon flights. And it's a really good question, of course, to what extent were they informed about the ultimate purpose, the controversial nature, the actual business risks of engaging on this for Rymdbolaget. My gut feeling, my guess would be that they didn't disclose everything, at least, and that Rymdbolaget might have good reasons to feel quite conflicted when this starts to become a really major issue in the public debate. And that could, of course, make them turn against Scopex also if they feel that they weren't really, you know, honestly briefed. But we don't know the details. I have not been able to figure out exactly what the contract looks like. We don't know. What we do know is that obviously Rymdbolaget has made this agreement to conduct this test. We have no idea how much money they will get. But they also know that it's not like they can't count on the cash, because obviously this advisory committee is going to give a green or red light on the 15th of February. So it's contingent on that, at least. So Rymdbolaget has there must be some kind of conditional arrangements here.
Yeah. But actually, the advisory committee is not any kind of governmental committee. It's a committee that is solely put together by Harvard. And hand-picked. And so Keith has tried to sell this as an independent governance thing, but it's not really independent.
And to say, just to fill in on that too, that wasn't part of Scopex from the beginning, and there's been, you know, people have followed this and monitored and fought against this in Arizona and New Mexico, etc. So there's been attention, and this was sort of a way to trying to be clever in kind of keeping a facade of some kind of process and governance and respectability. But there's been a lot of controversies around this committee because it's so biased, handpicked, and even the chair had to resign because it was found out that she was actually speaking she was communicating on the letterhead of the state of California. She's a public official, sort of giving the impression that this was all sanctioned by the state of California. And when that was called out, she had to resign because it was absolutely wrong. I'm not sure if she's been replaced. So already the committee has been in battles and is a bit tarnished, and it can be very much exposed in terms of its very sort of skewed composition.
Thank you. I'm going to go on to, we got a lot of questions, and we're going to, and also want to make sure I have time to discuss our plan of action. Martin Hedberg, you've raised an issue of ocean acidification. Would you like to raise it yourself?
I mean, I agree totally, and on everything has been said, but I also think that one needs to sort of address the situation that people who want to solve the climate problem just need to realize that there are way more problems. For instance, ocean acidification, of course, but the whole biosphere and all the other things. But out there in the media, sort of the narrative is that we need to cool down the planet, and that will solve everything. And that is partly because sort of the major narrative has been temperature is going up, and that is the problem. So the sort of mechanical engineering solution would address the temperature as the solution, and politicians and public follow that. So I also think parallel to just sort of redefining everything is actually to bring up the scope of something more than the temperature as the problem.
Yeah, and that's absolutely right. Actually, and the fact that the geoengineering does not do anything significant about ocean acidification has been widely recognized. Now, some people talk about, throwing carbonates into the ocean to try to buffer the ocean acidification directly, and do multiple hacks to try to address it, but you're absolutely right. But more broadly, you're putting the Earth into a non-analog climate state that has no real analogs with our current ecosystem. So things like, you have high CO2, but low solar radiation. CO2 is a fertilizer for some kinds of plants, but not others, depending on what the limiting nutrient. Also, you convert, although even if you reflect 1% of the sunlight, you convert a whole lot more of that sunlight from direct beam into diffuse radiation, which again favors some plants more than others. So you are actually doing a major disruption of the whole physical environment that life on Earth has been living with. And some of those systems take so long to respond. It could be decades before we even realized that something was going wrong, or even understood what could be going wrong. And so that's why it really is a terrible thing. And the more of it you have to do, the more non-analog your climate gets. So,
and just to add on to that people, I mean, the global average temperature is not even the problem, but at the same time, people need to realize that you are disturbing the teleconnections, and you might have cold outbreaks or heat waves or precipitation and all the other sort of weather system going havoc and on different places. So the global average temperature is something someone has never even felt. It's just a metric. It's a KPI.
Yeah, that's exactly right. I mean, there's been some work on what kind of pattern mismatches you get, but there's always a fair amount of pattern mismatch. But in terms of what it does to precipitation patterns like the monsoon and so forth, that's something where we have trouble. We have, after 50 years of doing simulations of global warming, we still have trouble saying where it's going to get wetter and drier. And now, if you throw in the additional complexity of albedo hacking, then you're making the system even harder to understand. And so, Yeah, so there are all those reasons for really worrying. And then you have to say, in terms of say climate wars and disputes, it's not even necessary for India for the geoengineering to actually wreck India's monsoons. If India just perceives or believes that their monsoon failure is due to geoengineering, then how do you resolve a dispute like that? We don't have the kind of models or understanding of the Earth system to unambiguously do attribution of that sort of thing, and so you create destabilization just by the existence of the technology, which actually does a lot of harm, but also can open up all sorts of doors to perception of harm. So it's just enormously destabilizing.
I could go on, but thank you very much.
Oh yeah.
Thank you, Martin. Thank you, Ray. I've got quite a long list, and I've noted the hands that are raised, and I've put you on the list here. But next up, we have Ina. Ina, you wrote a question in the chat, which I would very much love to hear the answer about. Maybe you'd like to give the question yourself.
Yeah, thanks, Alistair, for calling on me. I was just curious to hear what the Keith group responded to your presentation because you said you presented this presentation at Harvard. I'm sure that they're aware of all of these issues, but yeah, what did they say in response?
Yeah, well, they have, they're a very civil group, and that's part of their key to success. They don't look like Dr. Strangelove types, and they seem decent people despite what they're doing, and so the relationships are cordial. David Keith says that this termination shock is not a serious risk because we rely on all sorts of technology anyway, and why would anybody do anything so stupid as stopping geoengineering when it would have such harmful consequences? And then I just say, well, let's all drink bleach, right? People do stupid things all the time, and he says that, we're just doing it in case. It's just, you don't want to give the future, the gift of ignorance. We want them to understand it, and just in case you need it. And then he has this scenario, he pushes this idea that we would never do this to solve all of the problem. We would just develop this as an emergency measure to get to trim some of the warming off. And he thinks you could keep it in the box. He thinks moral hazard isn't a problem. And he also, thinks that, well, we wouldn't have to do it forever because we might have to do it for a couple decades, but by then we'll probably develop technology to suck CO2 out of the atmosphere. So I say, well, let's develop that technology first, so we know that that's actually available to avoid this millennial commitment problem. He said, well, we have to do both of those over. But the talk at Harvard was, the group attracts not just David Keith's in group, but it got a broader audience who do recognize the various problems I was talking about, and so I didn't change any minds among David Keith's group, but I do know that most of his students in the group don't go on and do geoengineering when they graduate. There are only a few that continue doing it. Most of them, switch to something else. So, but yeah, I actually resisted giving any talks for David's group for a long time because it seemed kind of pointless, because I knew I wasn't going to change any minds. But I have close collaborators in astrophysics at Harvard. And so I thought, okay, I will go over there on the ticket of the geoengineers, and I'll try to beat some sense into their head. And then my reward will be to spend 4 days talking about exoplanets with my friends in astrophysics, though.
Thank you very much for these answers. Now, I actually had Kevin next online, but he's very kindly allowing Freddie to come in ahead of him. So I'm taking Freddie as a raised hand. I know there are more questions in the chat. I can see you, and I'm going to be calling you afterwards. But Freddie, the word is yours.
Okay, I make it very short. I just wanted to underline what Raymond said before very briefly. that we also need the sunlight, the direct sunlight, not only for vegetation, but also for evaporation. So I think also what we know from paleoclimate, as soon as you disturb basically the sun radiation, you often get into serious droughts. And basically, I think this is, I mean, you look at the benefit of not warming the planet, but you completely screw up the hydrological cycle. And I think this is extremely dangerous. And I think there's no way that you could do an experiment where you know that you don't risk in running into this problem. So for me, it's a complete no-brainer that this is no option.
Yeah, I agree. It should be a no-brainer, but unfortunately, you know, a lot of people, there's momentum building in the United States, even within the Biden administration, to expand research in this area. I mean, I want to focus on what's going on in Sweden, but I'm also fighting battles like this, you know, within the some fringe of the Biden administration. But on the matter of precipitation, you know, the geoengineering boosters, they say, well, we've done these models and we make up these metrics of the combination of temperature and precipitation. And although we don't restore the natural climate, we get closer than the high CO2 climate. But that's all in the metric. You know, how does your metric weigh in, say, the risk of some Indian farmer about precipitation versus the risk of heat waves in some New York banker, you know, trying to walk down the street to get from one bank to another? I don't know what they do, but it's all in the metrics. And so these comforts, these comforting statements, well, we're making it closer. You know, is that when you say closer, is that population weighted? How do you weight things for various stakeholders? And it's not really closer, but you certainly shift precipitation patterns. It's been shown you can't so-called fix the precipitation and the temperature. And you can't even fix the latitudinal gradient of the temperature. If you make the poles the right temperature, you make the tropics too cold, and so forth. And so that, you know, there are problems, and I don't get much comfort from these so-called, you know, metrics that say, well, you know, it's bad when we do geoengineering, but it's not as bad in our metric as just letting the CO2 increase. Well, no, that sweeps under the rug the third thing. Well, why don't we just not let the CO2 increase, which is the only plan that makes things less bad? And why throw, just at a time when we are beginning to get our act together to actually decarbonize and renewables are getting cheaper, you know, why throw something into the mix that gives people another excuse to not decarbonize? The timing is just all wrong to do this. You know, maybe we should do some research on this, you know, after we get the emissions down to nearly zero. But until we actually show that we can do that, that's just completely ludicrous to just throw this into a mix. But another interesting thing in terms of what you were saying about solar radiation, you know, given that the aerosols greatly increase the amount of diffuse radiation, that actually destroys the ability of solar thermal farms to generate energy, because they need direct beam radiation to focus. So you
Yeah,
can
exactly.
you can still do
some plants
photosynthesis.
also do that, yeah.
Yes, yeah, and so different plants actually respond in different ways to diffuse versus direct beam radiation. So you do change ecosystems, but whereas regular solar cells, photovoltaics, can work with diffuse radiation, solar thermal farms need direct beam radiation, and you lose a lot of that. So.
Yeah, I mean, I think we soon will talk about how do we respond to that. You mentioned these metrics, which are used to say that the offset of cooling is better than what you get in terms of precipitation. But I mean, we know that the climate models even don't agree on precipitation changes for the global warming signal.
That's absolutely right. Yeah.
How do we think they would actually work for something which we have no reference to validate that?
Yes. And what's more, I mean, and these metrics actually are based on a model where you know exactly what radiative forcing you put into it. Whereas the deployment with the deployment in the real world, you know, uncertainties about microphysics, coagulation, particle size, water uptake, stratospheric mixing, we won't even know with any precision how hard you clobbered the system until you monitor it for like decades to get around natural variability. And so even if these metrics were perfect and the models were perfect, which they aren't, just the uncertainty in the actual forcing you achieved and the fluctuations in that from one year to the other, and that's going to make make things very difficult.
Can I just chip in, Alistair, on this point?
Yeah.
Just to alert, I think I mentioned it in sometimes before to some of you, but a very alarming thing that came up a year or so ago is this, talking about metrics, is the work that has been conducted in order to try to come up with a new metric, which is radiative forcing as a metric, and with the intention to even replace or have an alternative to carbon emissions. And that's been going on under the ISO, the International Standards Organization, purview, led by a carbon offset American guy. And it was found out by some Germans, and it's been sort of held at bay with also work through civil society, but it's a very worrying thing, because what this would do is, of course, to open up the possibility for offset markets on SRM. And then you have another set of pure business interests that would push this to become, with all the narratives that you presented, Raymond, to actually create very short-term business and profit interests for actors that we've seen how they've acted already in terms of offsets and the whole sort of slew of problems around these things, as we also exposed in our article. And this is kind of two bad solutions on, multiplied, the square. It's really on steroids, and it's been aggressively pushed. So I just want to alert you on that. But it also shows the sort of so many things, sort of you line the dots. There's some kind of more or less elaborate strategy in play. At least there are some definite aligned interests.
Thanks. I'm going to move us on, as I still have quite a long list of questions. I've noted the hands that have been raised, and I've put you guys in the queue. Now, Eric Peel, you've raised a question which, to the best of my knowledge, it's been answered in its entirety. But if I'm wrong, and there's a part of the question you feel that you haven't had an answer to, the floor is yours. Okay, no response from Eric. I'm going to then move on. Magnus, you have an interesting question. I wonder about new ice age. Maybe you'd like to raise that?
Yes, thank you very much. I was just wondering about the potentially very large potential in putting aerosol into the stratosphere. I think some time ago, maybe it was 10 years ago, I heard people talking about that it was quite possible for mankind to start a new ice age by putting not so much aerosols into the atmosphere. Is it old news, or is it still possible for us to start an ice age? And
so I actually had some inquiries from reporters about this, because there's a new American TV series based on the Snowpiercer movie coming out. So Snowpiercer is an absolutely brilliant Korean movie in which geoengineering goes awry and then creates an ice age. The Earth freezes over, and everybody survives in this long train that is continually going across around the equator. That's the Snowpiercer scenario. And so actually, I think in the stratospheric aerosol scenario, an actual ice age or snowball Earth transition is not that likely a risk, because it takes time. It takes time to either trigger a Pleistocene sort of ice age. You have to build up the glaciers, which takes thousands of years. And even for the snowball Earth scenario, where you freeze over the ocean and increase the Earth's albedo, well, you could do that because there are multiple states. After you freeze over the ocean, it stays frozen. because it reflects so much sunlight back. But it takes a long time to freeze over the whole ocean because of the heat capacity of the ocean. You'd have to persist in excessive geoengineering for too long, I think. You would probably notice the ice advancing, and then you could reverse it. And so, the messaging here is complicated because people then take away the message, well, okay, the geoengineering is reversible, so the risks are on the downside are not so bad. But but what that ignores is, so I do think that's true from the standpoint of the ice age scenario, that if you saw an ice age coming,
to the limit. That's
that we're not close enough to the actual bifurcation that you risk tipping yourself over into an ice age before you actually could notice it happening. But the fallacy in the reversibility scenario or benefit, which is something that the geoengineering boosters push on, is that at the same time the reversibility property of stratospheric aerosols means that you can reverse it if you see an ice age coming on. Means that you can't. It also means that if you stop doing it, you get this rapid warming. So the same reversibility gives you the termination shock problem. There are scenarios, science fiction-y scenarios of different kinds of things other than sulfide aerosols that you could throw into the stratosphere that wouldn't be reversible, that could run away. For example, if you bred bacteria, there are bacteria that live in the stratosphere. If you bred bacteria, that were self-replicating and had high albedo, and then they started growing faster than you thought. Yeah, I mean, you could actually freeze over the Earth that way. And people, so some of the nanotechnology people talk about, off in the future could lead you into risky scenarios like that. But I think that's not any of the risks that's on the near horizon with what people are actually have the capability of doing. But there is a smaller version of the ice age risk that people never talk about, which is that the stratosphere does not just let you keep your aerosols put where you release them. The stratosphere has all sorts of complicated dynamics, sudden warmings and things like that, which bunch up the aerosols. And so although the optimal thing is to have a nice even spread of aerosols, if you have some weird stratospheric circulation of sudden warming, or what if you have a volcano like Pinatubo goes off, the same after you've already released your aerosols, and you can't sort of suck them back out. So there are all sorts of possibilities for causing regional crop failures, something like a nuclear winter, although through reflection, not absorption. So there are all sorts of things in unintended consequences where the sort of unpredictability of the aerosol forcing could lead to seasonal regional problems, which could cause crop failures and things like that haven't really been worked out. And there again, the sort of things that you could try to simulate in a model, but because of all the uncertainties about aerosol microphysics and even stratospheric winds, you can't actually answer those questions until you're actually doing it at scale. You won't see this sort of thing, the risk of this sort of thing, until you actually see it happening.
Great, thanks very much. Our situation now, it's 7:25. Our session goes on till 8 o'clock, and we'll be stopping definitely there. But what we've got, I've got two more people who are raising questions. That's Toya and Bengt, and Kevin's leaving us at 7:30. Now, Kevin's already raised in the chat that he's very happy to contribute to an opinion piece about this issue in Swedish media and help draft us with that. And I'm absolutely certain that's got to be one component of our path of action. So before I let Toya and Bengt in, Kevin, is there anything you'd like to share with us before you need to leave about that?
No, other than to agree with all the statements that have been made, and thank you, Ray, for the wonderful presentation. It's always a pleasure to listen to you. Ray mentioned a report by the U.S. National Academy of Sciences that he was one of the co-authors on. There's an older report by the Royal Society in Great Britain that's actually quite good as well. So there's a lot of documentation that could be used as the basis for some sort of an opinion piece that says, as Ray's been saying and everybody else, this is just completely bonkers. And the scientific community is aligned with this being completely bonkers. And please don't make Sweden the new face of complete bonkership. So I think we could easily put together something like that, and as I mentioned in the chat, I'd be very, very happy to contribute to it.
Yeah, I mean, I would actually love to. Yeah, I was thinking. I mean, I really admire Dagens Nyheter's science coverage, and getting an op-ed in Dagens Nyheter would be great. And I would be very happy to collaborate on an op-ed in Dagens Nyheter. And so and I can read Swedish perfectly well. I need help in writing anything in Swedish, but I think we could turn something out.
Well, that'd be great. And you know, Nicholas, I'm sure that you've got plenty of material as well. So you know, I'll be very happy, and I would encourage us to quickly develop an opinion piece that just is quite candid and says bonkers.
Yeah.
Don't go there.
Yeah.
I like this a lot, as this is a nice piece of action. I'm going to move us on now. We're going to come back to. I just want to let Kevin have mentioned the opinion piece already. I'm going to move. I've got now 3 questions still ahead of us, and then I think we actually need to discuss where we're going to go forward. So I have got Toya, Bengt, and Monica, and then I think we're going to move into a discussion of action, what we're going to do. So I'll take those last 3 questions. Toya, the floor is yours.
Yes, thank you. It's very intimidating to sit here with all you guys and
You
girls.
are our heroes.
But yeah, I'm just thinking we have all this pollution and it's cooling off because of certain, I don't know how it's put together, but and if we were to cut off all pollution today, it would rapidly get a lot warmer. Yes or no? Can someone nod?
Oh yeah, yeah. So
Yeah.
I mean, actually, so yeah, that is the yeah. Again, since tropospheric sulfate aerosols wash out in 7 days, if you were to stop all dirty coal burning, you do get a warming by an amount that people are still arguing about, due to the reduction in coal burn, a reduction in tropospheric aerosols. And so, you know, a scenario that I could see as justified for stratospheric geoengineering is if you say maybe we have a 0.5 watt per square meter of aerosol forcing from dirty coal burning in the troposphere. I don't know whether it's a 0.5 or 1, and it depends on cloud of feedbacks and things like that. But let's say that we knew that you had at least a 0.5 watt per square meter of radiative forcing from tropospheric aerosols. You're going to lose that when you stop burning coal. And so you say, well, okay, the stratospheric aerosols are definitely less, or they're more innocuous than the tropospheric aerosols. You don't need as much mass of sulfur to do it because of the higher persistence, and they last longer. And so we'll just allow an offset of just a 0.5 watt per square meter and stop there. Yeah, and so I you know, in an ideal world, I think that actually could be a reasonable use of stratospheric geoengineering. I think that where that fails is that we're not in an ideal world, and I just don't imagine once you deploy it at the level of a 0.5 that people will be able to stop there. It's like, you know, it's like opioid addiction. They'll get addicted to just using geoengineering and pumping out more CO2. The other problem with the 0.5 watt per square meter scenario, we can't actually monitor the Earth's radiation budget to an accuracy of a 0.5 watt per square meter. And if there's any kind of research that's needed, if you ever thought geoengineering would be a useful thing to do at some level, it's just to monitor the Earth's radiation, but learn how to monitor the Earth's radiation budget better. That helps everything. And so the kind of research we actually advocated strongly for in the National Academy report was exactly that sort of thing, making better use of volcanic eruptions as a natural experiment, learning how to monitor the Earth's radiation budget accurately, learning more about cloud feedbacks. All those things actually would be underlying scientific understanding before you can even think about whether there's any conceivable justification or scenario in which there's benefit in deploying it. But
Thanks very much indeed. I'm going to hand over Bengt. Would you have a question?
Yes, thanks, Ray, a lot for your presentation. I'm curious about how you consider the attitude among the proponents for this hacking. I could imagine they are technological optimists or optimists in general, but I'm not so worried about those guys. They may be as they are, but we are used to these people. But I'm more worried about if they are pessimistic, in the sense that if they believe seriously that the mitigation of CO2 emission, etc., will not be successful. So, I mean, they can certainly point at the tendencies today and say that I don't think humanity can make it. And so we have to develop skills, plan B, at least in the possible situation that we will need it in the future.
No, you're absolutely right that at least in terms of the uninformed public perception of the justification for geoengineering, it's the Plan B scenario, which is why I've tried to point out the fallacies in public pieces and about the Plan B scenario, because in fact, if you're a pessimist and you think, well, in order to think that the geoengineering solution is workable, you actually have to be an optimist, because the only situation in which it actually can be conceivably useful is one in which you have gotten the CO2 emissions down to nearly zero. And so it does raise the question, what if we are just not going to get the CO2 emissions down to zero? And the sad fact of the matter is that there isn't any Plan B. But so given that there actually is time to get the CO2 emissions down to essentially zero, and we have the technology to do it.
Yes.
The first step in curing our carbon addiction is recognizing that there isn't a Plan B, that any alternative is really, really bad.
I see this and I agree with you, but I'm curious about how they conceive the situation, and in particular, how they will conceive it, say 10 years ahead, if we don't have succeeded in decreasing the CO2 emissions.
Oh yeah. I mean, and that is an issue. That's, I mean, and some of the environmental organizations like the Environmental Defense Fund, which is one of the major U.S. NGOs, they have been collaborating with the geoengineering governance people exactly because of the Plan B notion. And even when Paul Crutzen wrote the editorial that launched attention on this, he was basing it on the Plan B scenario. And I don't think he really thought it through, which is what the problems are. But that is the risk. In fact, in the U.S. Congress, it's really the Plan B notion that we need this just in case. That is really drawing a lot of people into it, and so that's something I'm very worried about.
If I think
so I'm conscious now that we're needing to move towards our discussion of action. So I'm going to let our last questioner in, that's Monica, and then we'll carry on from there. Monica?
Well, I wanted to talk about communication. So I don't really have a question.
Okay, so we're actually going to, your participation is in the discussion of our plan of action. In which case, Bengt, did you have a very short last comment you wanted to make?
Well, it's actually going to the plan of action. I could just add one or two sentences on that. One is that one argument one could have in pointing at the situation could be that, look here, people are starting doing these kind of things, showing that they are getting desperate. And I think desperation here is not what we should have of this sort, but there's a risk, and that may be increased. And secondly, my second thought is, of course, the people defending this hacking will say that, look here, we are only doing small things which are not at all dangerous at the moment, and therefore it's a question of freedom of research, so let us do this. And I'm a bit afraid of the Swedish colleagues we have. I've discussed this with a number of them, that they may go to that argument and use that against. So I suggest, if you write an article on this, you should meet this very argument before they present them. You should say that, all right, people think it's maybe a question of freedom of research, but look here at the future consequences.
This is a real good point, Bengt. And when we're looking at, and this is why we have Researchers Desk, we're a huge team here who are going to be able to make sure that whatever opinion piece we put out has got all these sort of bases covered. Thank you very much for that input. Ray, did you have a response? Thanks.
Oh yeah. I completely agree that one of the thorniest issues, sort of the combined difficult issue Bengt pointed out two difficult messaging issues. Okay, the first is the panic, because in some sense you want people to panic. You want people to recognize there's a climate crisis, we need action. But the problem is that when people are in a panic, they do foolish things. And so one of the foolish things is to turn to what look like cheap techno fixes, like global warming. So actually getting the right, mobilizing the panic and leashing it into the right direction by giving people hope that we actually can decarbonize. That's a difficult messaging thing, but it is one of the critical things. And the second thing Bengt pointed out, which I completely agree with, is that it's uncomfortable for scientists to say, don't do this. The academic freedom is something very dear to all of us. And so there's one part of it is it's just research, and one part of it is academic freedom. But I think everybody would agree that there are some kinds of research we'd be better off with. Like if no one had invented sarin nerve gas or Novichok nerve agent, we'd be better off. So you have to ask the question: where are the boundaries of academic freedom? There are some things that we are better off without. And I would argue this is one of them. And also, if you look at something like CRISPR, gene engineering technology, CRISPR has the potential to make engineered pathogens and increase biowarfare possibilities, but it has a lot of definite positive applications. And geoengineering research has none of that. It's targeted at just exactly one thing. Just like sarin is targeted at exactly one thing, which is killing people more effectively and more painfully. And so, I would say that it's just research and academic freedom argument. It has boundaries, and it's always had boundaries.
Thank you, Ray, and thank you, everyone. This has been a really, really fantastic discussion. I want us to spend our last 20 minutes now moving towards taking action. What are we going to do? I would like that we leave this meeting with a concrete plan, that there's going to be action taken. Kevin's already suggested the opinion piece. We have some experience of doing that. We've done one fairly recently that had a lot of effect. That's certainly sounds to be a way to go. Bengt's already flagged for us one of the key things we need to be thinking about when writing that. Ray said he's willing to be a part of that. I don't know if opinion pieces is even the way forward. I'm not an expert in this. Monica, you are an expert in communication. Nicholas, you are. Maybe you guys can, Monica, do you have a reflection? Nicholas?
Well, I was thinking of all the other ways of, all the other communication channels. I mean, Has anybody talked to Klimatpolitiska rådet? Has anybody approached the ministry? If SSC is doing this off their own bat, maybe we should be talking to the ministry directly. Perhaps we should be talking to SSC directly and raising concerns and saying, you know, we want to stop having to go public about this, but we see huge problems. Can we talk about it? So things like that.
I'll talk to Klimatpolitiska rådet tomorrow. I'll contact Geoengineering directly. That's a really good point. So really, yeah, that's.
And I think, sorry,
go on.
I think we can also consider TV as being much more effective than opinion pieces in the press. And Geoengineering goes on TV4, but he's also very, very polite. So we'd have to sort of pepper him up a bit, or add another researcher. I'll stop there.
Yeah, no, I think actually getting the word out through multiple channels is critical, and I guess the print media has a little bit more reach now that people are reading it online. But I agree, you know, getting it on TV, but if finding a way to make it go viral on social media is that's a big channel too. That's a little bit unpredictable, but I think that once word gets out in Sweden about what Harvard wants to do and who the tech mogul billionaire backers are of this sort of thing, I think opposition will rise up pretty quickly. And right now, nobody knows about this outside of a little circle. And so the more we can alert the public, the better is my feeling about this. But I absolutely agree that getting in touch with the channels in government and NGOs who are stakeholders is extremely important, because it's probably not on their radar screen either right now. And there's a question of timing. You know, do you make a big splash in the public first, or before, or do you contact people sort of on the quiet in the government first and get them to kill it off? But the thing is, I'm in favor of making some kind of splash in public, because if you get it quietly killed off, then Harvard will just come back in some other sneaky way of doing it. They should feel the heat for even having tried to do this.
Thank you.
Yeah,
Nicholas.
So this is great, such an excellent conversation and so important. Lots to think about here. I think a couple of points on the sort of actions and communications. I think that we should see this in a bigger frame. I think this really aligns with the Dagens Nyheter op-ed, for example, where, you know, it's about framing exactly what you said, Ray. You know, this is about getting to zero emissions as fast as possible in an equitable way, and that's what we need to really focus attention on. There's no other plan. That's the only plan, and this gives us some avenue actually to elevate that. So I think we should think of this as not just, you know, exposing the risks and killing this, but to see it as an opportunity also in the framing to really advance what needs to actually happen. And so we just kind of keep that in mind. And that also means that you don't just want to have it kind of quietly go away and they do it somewhere else. It's about a larger piece, right? This is beyond Sweden. Given that, I think that it is, I also agree there, it's probably the best is to have a buzz and a lot of action taking place in more or less coordinated way. Then it gets really powerful. And so we don't need to have every, you know, we can have different kinds of sets of actors and peoples and actors doing things. So the research community and this group, of course, can play an incredibly important role in so many ways, not only as a unity, but also where people are, you know, acting in other capacities and so on, and just popping up in different kinds of settings. In terms of what seems to be happening now, there is, as I said, action within civil society. I think that there will be international media coverage fairly soon, certainly before the 15th, maybe a week from now or so, and letters sent to the government and to the Space Corporation. So that will stir up much more than we've seen so far. So that's, I think we can sort of plan around that in the sense that, you know, people might be wanting to be ready to be, you know, in media as things maybe then probably snowballs in Sweden, but we can also be proactive in reaching out. And I think Bengt has been thinking a bit about science journalists, and you all have different contacts. So some kind of plan for that. And of course, the idea of an op-ed has been coming up from various places. You might want to synchronize a bit of that, but I think several op-eds would be great. And then I think also would be good for those who want to be working on this more. It would be really good to have set up some kind of opportunity to interact with those who are already active in civil society as a sort of you know, strategy kind of interaction opportunity, and a bit of coordination and synchronization. So I'm happy to be a bridge for that. And yeah, I'll leave it at that for now and get back.
Thank you, Nicholas. Thank you very much indeed, Nicholas. So I think one of the things we need to remember is who we are. We are a researcher's desk, and one of the absolutely most powerful things we can do is provide provide the science. And the science, I think, says no here. So it's a very clear no, actually. One of the clearest no's I've ever heard. So I think that's something that we can think of what our role is, what we can contribute. Eric Kust, you raised your hand.
Yeah. First, thanks, Ray, for an excellent presentation. And this was fairly new for me, even though I knew about geoengineering as an earth scientist. But I thought of two things. Well, we can write an op-ed, but also we call deserved attention, as we call in media. Just to tip, we have a lot of really skilled science journalists, both in TV and newspapers. And now Dagens Nyheter, the biggest newspaper in Sweden, have another very skilled reporter, Peter Alestig. He came from Svenska Dagbladet. So now Svenska Dagbladet have a tough time. But we could tip them about this issue, and also inform the Nordiska Rådet about this. So then we can start rolling snowballs, and researchers desk, we have the capacity about the knowledge and the science behind it, and to be a resource. So that's actually an idea, just to because if Maria Günther or somebody else at Dagens Nyheter writes about it, she's a physicist by herself, so she will understand this in 1 second. Imagine a full 2-3 pages in Dagens Nyheter about this. And she writes that, and some of you are scientists or interviewed. That would be the best attention, and that can go viral. We can tip Greta about it. And when she highlights something, the world knows. I can tell you.
Yes, that's really great.
So that's also an idea.
Yeah. No, in fact, I think what you said about science journalists is especially important, because op-eds are short, and actually there's a lot of noise level in op-eds. Newspapers, even the best ones, publish a lot of garbage as op-eds, and so they're good for getting the word out to some extent, but it's hard for they're not seen as authoritative, because if you have a respected science journalist, first of all, they can get more space, get a lavishly illustrated thing, and they can be persistent about it. They can get more than one article, and I guess the trick is for them to see it as newsworthy, and this seems intrinsically newsworthy to me. And I read the Dagens Nyheter science coverage. I read the whole thing pretty religiously, and I really am really impressed with it as a newspaper altogether. And so yeah, enlisting those science journalists. So I'm in touch with Bill McKibben, who writes regularly for the New Yorker, and he is not going to sort of jump on this particular issue until there's something kind of in the news about it. We need a little buzz first. But he did ask me to keep him posted, and if it gets big enough, it's the sort of thing that I think he can cover in the New Yorker, which gives us even more of a platform.
Yeah, that's true. I mean, New Yorker is a great magazine as well, both news and humor.
Yeah.
So I'm going to summarize what I understand our plan is so far. We're going to tip off our mainline science journalists, and we're going to offer our services to be ready as scientists to comment as they wish. But in the first instance, our plan is to put it in their hands, into the hands of, say, Maria Günther or whoever, DN or Svenska Dagbladet or whichever. I leave that to you experts to decide where. And then maybe the backup plan is doing an opinion piece if they don't buy. I'm sure they will go for it straight away. As soon as there's some, I think for Greta and for the youth movements, they will want something to refer to. So we kind of need to get something written. So there's something that Greta was very helpful in spreading our last DN opinion piece. I'm sure that she and all the other young protesters will be horrified when they hear about this, and will very definitely want to spread it. But I think we need to give them some substance to spread.
Yeah, the idea was that if, for instance, Maria Günther, whom I know, if she writes something, then we have something to spread to Greta or to the other to get viral. But you need.
I'm happy. First. Yeah, and of course, I will make myself available 24 hours a day to any reporter who wants to talk about this.
Yeah, I mean that is kind of key to success, and also the key for credibility. To have and actually these journalists are really skilled, but they also need help. They need us to for information about what's happening, because they cannot cover everything. It's too much for them. So we can. It's good to see yourself as a help to the journalists, and if you go hand in hand with them, then we'll create good media. And the world needs good media coverage about important things based on science. So
if I can just briefly jump in there, things that are happening right now. So there will be an article in the New Scientist on Thursday about this experiment based on interviews with the Harvard team apparently, and the guy who's writing the article also contacted me to give a comment on this. So I said something about this crossing the Rubicon thing, and that if you cross this natural threshold, you'll get into a whole load of slippery slope issues and so forth. So that could be like a first thing that other journalists can also pick up on, and I'm happy to share that when that comes out. Another thing that's happening here in the Netherlands, so far as I know, is that there's some high-ranking scientists who want to put out an opinion piece or a commentary in Nature Climate Change. I'm not sure how far that is going right now, but they've been in contact with parliamentarians here in the Netherlands, and they want to put out an opinion saying there should be a no-use agreement at international level. So no use of SAI in any form. That's still in the very beginnings of developing, but as far as I know, Frank Bierman, who is leading this, he gets things done very quickly. So we'll see how fast that goes. But just to say that in the Netherlands, also people are starting to think about this and talking to politicians. And then one more thing in terms of thinking about context, I was just thinking in terms of history, what we know of regulating geoengineering. I mean, what we can compare to right now is sort of the ocean geoengineering, the marine geoengineering experiments that took place earlier, and the context that allowed for international regulation to take place, which was basically the announcement of an experiment conducted by private actors. So before that, there were scientific actors going on doing experiments. But then at that point where a controversial private actor started wanting to do ocean geoengineering at large scale, this whole thing came up in the Convention on Biological Diversity. It came up in the London Protocol, and that's sort of the moment when international regulation started taking place. So if you see this example as another sort of trigger like this, so I think that builds on what Niklas was saying earlier. It's good to see this in an international context. What kind of implications could that have, and what you want in terms of governance of the thing overall? Then you could use it, if it's done well, it could be used as a way to trigger discussions on governance at an international level. And seeing as these have already been brought up into the 2019 by Switzerland and a couple of other countries, that sort of same discussion could be warmed up again, essentially, by this example.
Thank you, Ina. It's going to be really useful having, I hope you're going to help us with this, the process. I understand from an email you sent me, you have a lot of expertise in this area, so it's going to be really great. It's 5 to 8, and we need, and now in Sweden we have someone who's always called a salmon calendar, who's going to lead the action forward. And I'm not closing this meeting without that person having volunteered. And my feeling is, Niklas, will you lead us in the action taking process?
I'm happy to do whatever I can. It would be great to have someone else as well. I think I'm involved in several bits on this. So it would be good to have somebody else as well to work with me.
Eric as well. You guys work together extremely well on.
We're like that.
You're amazing together, and you're not on your own.
He's in a pod.
We have because you've got an entire team together, but we just need some. And take advantage of the full power of Researchers Desk and all the people, and Ray who's joined us, Ina who's joined us, Bengt who's joined us today, and make sure to use all those resources you have. But we need to put the ball in two people's hands. That's Niklas and Eric, so that this doesn't get dropped. And I'll be on your case if nothing happens if we don't hear from you within the next few days. I'll be on your case.
Oh, that is scary.
Yeah, that's scary. You're all scared of me.
Yeah, actually, Alistair, or whoever is the host of this meeting, I wonder if you can say, there are a lot of good comments in the chat and some questions that I didn't get, that we didn't have time to answer. If you can just make sure to save the chat, because I don't have the authority to save the chat, and then send me a copy of it. That'll help. In fact, that'll also help us remind us of what we wanted to do.
Yeah, we'll definitely do that. Toya, are you capable of doing that, or shall I? You can do that at your end, I think, Toya. Can you?
Hold on. Yes, I can. It's always saved. Yes.
Fantastic. Thank you very much.
Excellent. Good. Thank you.
I think we've come to the point. We now have 2 people who are going to lead this, and it is now almost exactly 8 o'clock. I want us to give our appreciation to Niklas and Ray. I know you want to say something, Niklas. I'm going to let you. Don't worry. To Niklas and Ray, and of course Toya, who organizes Researchers Desk and has brought everyone together as always. So a round of thanks and applause for everyone. Thank you very much indeed. And everyone else for this really dynamic session. Niklas, you have 2 minutes before we shut down. Would you like to have the last word?
Not necessarily, but just quickly, I think you said in the chat too, Ray, that you have a set of stuff that you've been presenting, and including the one you shared from Harvard. That would be great to get that quickly. I think everybody would appreciate that, and very useful. Yeah, this is exciting. I think also what's exciting here is that, and as having followed these issues and worked closely with people who've been, as you said, Ina, these things didn't happen by chance, right? These things were put on the radar. There is a moratorium in the CBD. There's been calling out of these experiments and this private actor that did ocean fertilization and so on. Most of this was done by initially a group of 5-10 people, particularly the ETC group that I mentioned, and then a network of people, but mostly in civil society. It's been an incredible deed so far to really damage control a lot and get quite a bit into the international media, but it's sort of still been you know, very limited in terms of the overall public debate. And I think what we're seeing here is super interesting, because I think we can have a much wider collaboration and more scientists involved doing what they can do, what you can do in your capacities. So I'm really keen to, as one early step here, also to put some of you all in, you know, to as I said earlier, to facilitate some interaction. We have different roles, but more communication and learning and collaboration, I think, will be really, really useful, because that's needed to get the grip on this. So I just wanted to say that, and also just to say that I think Bengt has also been already maybe initiating some contacts with science journalists. That's been part of our conversation on this that we've had for quite a while now, and so I think we should synchronize, of course, and find the best way to advance that. And thanks to Alistair, who's such a brilliant chair, getting everybody to speak and having this relaxed kind of way of having a very intense conversation and ending on time. That's pretty amazing. So thanks to you and to Toya, as always, of course, for making this possible. Very, very happy you're all joined.
Thank you very much indeed, Nicholas. Ray, just before we close, do you have any parting comment for the group?
Oh, just Sweden, you know, for decades has been like a second home to me. It's one of the places in the world I feel most at home. And I spent so much of my time up north and in Stockholm, and I have so many friends among you, and value my time there. So if this, and I've written about how Sweden is kind of a beacon to the rest of the world and how to actually decarbonize, and the good progress that's been made. So it would feel like a personal affront to me, like David Keith would have personally wounded me especially hard over this, if it turned out to be in Sweden that he finally got to have his way with the sky. So I'm really fired up about this. But
I will add, I'll say, over our dead bodies, he will.
Yes. Yeah.
We are, so Nicholas and Eric, you have the researchers desk at your disposal to write whatever you need. And I know I've heard Ray and Ina saying they're happy to back us and support us. Thank you very much for this excellent researchers desk session. You're still trying to get in there, Nicholas.
Yes, I have a question, which is for people who are perfectly aligned with this conversation that aren't in researchers desk. Ray, as asked you about the recording, are you comfortable in sharing your presentation, and are people, you know, to what extent are people comfortable in sharing any of this or not? That would be just good to get an indication of.
Nicholas, I'd like to handle that in a different way. I would say that if anyone is uncomfortable, all you need to do is send an email to the researchers desk after we close the session, and that will of course be respected. But my understanding for the presentations, Ray and Nicholas, are they okay to share?
Oh, I'm perfectly okay to share those. Yeah. Yeah.
But for the chat itself, you can, if anyone emails, we promise that it will be anonymous. If anyone emails saying no, I prefer that isn't shared, it will be respected.
Yeah. Good.
Good.
Thank you all very much. Have a lovely evening, and
I'm going to
enjoy winter. It's here, thank God.
Yeah, I'm going to have a wee dram, but it won't be a dram like you've got. But
you have a wee. I'll drink one with you from the snowy Sweden.
I ran out of the Port Charlotte and I haven't gotten more in yet. But
Ray, Lefroy do emergency deliveries. I'll send you some details.
Oh, okay. Yes.
Yeah. I've had a 12-pack delivered over here.
Oh, okay. Yes.
No, it's that we're in lockdown. You discover these things. Anyway, take care, everyone.
Okay. Cheers.
Bye-bye.
Bye.
Cheers.